All right, chemistry classes. This is something I'm kind of trying so we can use our class time more effectively. This will be your pre-lab video for the chalk lab, which is going to be a percent composition lab. So with that in mind, you all should have gotten that piece of paper, and we know in our moles chapter we're analyzing matter very, very specifically as far as its percent composition. So a little bit of background. I mean, I don't know if you know this or not, but if you were to, as a kid, tear up paper and eat it or stuff like that, it tastes like chalk. If you didn't eat chalk, I mean, I know quite a few of you in our class did, just based on your overall development. But there is chalk in paper. It's one of the things that's made. So you'll all be using the same kind of paper. So what we're going to do is start introducing some chemical reactions, and then we'll practice some moles calculations as far as getting the amount of chalk in paper. So that is really what we're going to be doing in this lab, is figuring out how much chalk is in paper. Now, specifically speaking, chalk, like it says right up here, is known as calcium carbonate. Okay, so that's a formula you'll see in a minute here, but I'll have the lab mostly set up for you guys. You'll have beakers, you'll have some wire gauze, those are the little squares. You'll need distilled water, not tap water. You'll get paper towels as needed. I'll have tongs and then tweezer forceps out for you. You'll definitely need a scale. This is going to be a very analytical lab. You'll use a hot plate and a ring stand, and then we'll use hydrochloric acid, which is obviously a pretty big deal as far as our safety. So we'll definitely need goggles on tomorrow. But again, just a little bit of background. I mean, calcium carbonate we actually use it in quite a bit in the world, but that is the name for chalk. If you go into the industrial world, you'll learn that we use it for a lot, but that's what we're going to be isolating. In order to get the chalk out of the paper, we're going to be using acid. The acid we'll be using is hydrochloric acid. To really help kids understand that, I'll kind of introduce the chemical reaction. So this is a little bit down your lab page there, but chemical reactions is our next chapter, where right now we're just learning about analyzing the number of particles of substance number one. We'll next chapter start mixing them, so this is fine for us to talk about. So what we'll start with is the word equation, and then underneath you can write the chemical formulas, but we already know we're going to be taking chalk, and what we'll be doing is using hydrochloric acid to get the chalk out of the paper. So when we go to do the formula for calcium carbonate, we know that calcium is +2 and carbonate is -2. And like it says right here, acid is actually going to degrade the paper, and what it's going to do is it's going to break down the chalk in that paper and remove it. So afterwards, the paper, it'll still be paper, but we'll have taken the chalk out of it. And that's what we want, is we want to see how much chalk is there in paper. So we should all remember that acids always start with H, and hydro means it's just with one thing. So the formula for what we're going to be dealing with for our reactants is that we're going to be taking calcium carbonate, the chalk, and mixing it with acid. Next unit, we'll learn that this is going to be called a double replacement reaction. So this cation is going to go with this anion. Your test is on the orange folder. Go ahead and just start working. And what that's going to end up doing then is that calcium, a +2 ion, is going to now bond with chlorine, a -1 ion. And that's going to make a substance that you should be able to figure out. And then hydrogen, that +1 ion, is now going to bond with carbonate, a -2 ion. So what that's going to end up making then is H2CO3. I know my camera's in the way here, but that's carbonic acid. And you can see that I have 2 dashes over here because that carbonic acid is immediately going to break down into 2 things. It's a fairly weak acid, so it's actually, if you kind of look at the letters, it's going to break down into water. You can see the H2O, and then that would leave CO2 left. Those, everybody, are the bubbles that you'll see. So when you really have it all done, those will be the products in our beaker at the end when we've gotten the chalk out, and the carbon dioxide is going to be gas bubbles that you can see. That's how we know a reaction's occurring. So I think there's a spot where you'll have to write what's happening, but make sure before lab starts you need to go through and you'll have to name those compounds. That's an important part of just what we're doing this quarter. So as far as pre-lab questions, these are things that I expect you to have done before the lab, so I'll help a little bit. What's up? It should open the orange folder.
I did. I set it on your desk yesterday.
So the whole point of the lab is to find the percent chalk in paper. Now, if you're all using the same paper, all of you should get about the same percent, and that's what we'll see. But again, we got to always in life start with the end in mind. So if the whole goal of the lab is to figure out the amount of chalk in paper, there are 3 things we're going to need. When we go to really think about what those are, we know that percent is the part divided by the whole. And what we know we're going to get is the chalk. I mean, that's the percent chalk. We want the part chalk. So in order to get that, what we'll need to know is how much our paper weighs before, and you probably won't get a whole piece of paper. You'll need to know how much your paper weighs after, and think about it. Will it weigh more or less? The answer should be that it will weigh less, because what will we have taken out of it? We'll have taken chalk out of it. So just making up some numbers here, let's say your piece of paper beforehand weighs 2.55 grams. Let's say afterwards it weighs 2.20 grams. Why would it weigh less? Because we've pulled out that much chalk. Then you would have your part of it that's chalk, and you know how much the whole piece of paper weighed. Then we take it times 100 and get the percent. So make sure we're kind of keeping that in mind. Otherwise, when you go to do this reaction, it's important. It's going to be wet. You're going to want to make sure you use forceps to pull it out of the acid, because obviously we don't want to put our fingers in there. And we need to think about how to speed that up. I mean, the reason we're doing this video today is so that we don't waste class time tomorrow talking about it. But all I would say is when you have a towel that's all wet from the state lakes, do you throw it in a ball in the back of your car? No. You open it up and spread it out and make sure that it can dry faster. That kind of works into number 3. In order for your piece of paper to fit in the beaker and react and speed up the reaction, you don't want to crumble up this piece of paper. We're going to want to tear it up. Just make sure we're reasonable when we tear that up. I mean, the more pieces you tear, the more pieces you have to dry. So we want small, probably inch by inch pieces or so, and that will also speed up the reaction, because the acid will be able to get to it more. As far as number 4, I mean, you'll see tomorrow that the chemical reaction's happening. If there's bubbles and it's hot, as long as there's still bubbles going, it's still getting chalk out. But if you feel like the bubbles have stopped, that would mean you've now gotten all the chalk out of that, okay? So last but not least, this is kind of a silly question, but how do you cook a hamburger on a grill, even though the hamburger isn't touching it? If you just let your paper tomorrow sit out and dry, it will take 4 to 6 hours to get dry, if not more. We need to speed that up because our class time is only 88 minutes. So when you cook a burger, you don't actually put the burgers like on the flame, but you put them up above it. That's called convection, where the hot air rises. You'll be doing the same thing with a hot plate. So we don't want to put your paper right on the hot plate, because that would burn the paper and it'll get black and crispy, and then your data will be messed up. So what you'll do, and you can kind of see in this picture here, you'll kind of make a little Burger King setup, and you'll fry your pieces of paper like burgers at Burger King. So I'll try to give everyone multiple different ring stands and rings so you can do as much as possible. But if it's not drying, move it down and get it closer to the heat and crank it up, because what you'll have to do before you leave tomorrow is weigh your paper and figure out how much is it after, so you can figure out how much chalk it lost. Okay, so otherwise, yeah, we'll use that setup, and I'll try to get you as many as I can. But otherwise, you'll make observations as you go. You'll weigh your paper. You'll talk about what the reaction was, and then ultimately the whole point of this lab is for us to analyze atoms and particles. So everyone will have just 7 practice problems after. These are good quiz and test questions analyzing your chalk and your paper. And again, what we'll put up on the board is what everyone got. So our paper that we use at Fremont High is definitely not 70% chalk. I mean, I have a pretty good idea from the manufacturer what it is, but we'll compare all those and we should be close. So we'll be analyzing the percent chalk and paper. This gets you set up on what you'll need to know for tomorrow. So be ready to rock and roll. We'll probably go right into lab.